A certain first-order reaction has a half-life of 40 minutes. Calculate A, the rate constant, and B, how much time is required for this reaction to be 75% complete. So, if we remember from the previous video, our half-life equation for a first-order integrated rate law will be 0.693 is going to equal kT to the 1/2, where T 1/2 is the half-life. Okay, we know that the half-life is going to be 40 minutes, so 0.693 is going to be K times 40 minutes. If we go and do the math for K, we get 0.0173 minutes to the -1 power. Okay, so then for part B, we can use this value that we calculated here to calculate now part B, which how much time is required for this reaction to be 75% complete. All right. In this case, we're not at the half-life, we're at 75% completion, so we need to use our integrated first-order rate law, which is the ln of the concentration of A naught divided by A at any time, the concentration of A at any time t. That's going to equal K, which we just determined to be 0.173 minutes to the -1 power times t. Okay, we're going to be solving for t, which is the time required for the reaction to be 75% complete. Okay, at time equals 0, our A naught is going to be equal to 1, or we can say 100%. Okay, if we go to 75% completion, that means 25% of A remains. So our concentration of A at any time t is going to be 25% of what we initially started with. If we write these in a decimal, this will be 1 and this will be 0.25. Okay, so now we'll go and use the rate law. Our initial concentration of A is going to be 0. Our concentration at any time t is 0.25 in this case. That's going to equal 0.0173 minutes to the -1 power times t. We solve for t, which is going to be the ln of 4 divided by 0.0173, and that's minutes to the -1 power. And if we do the math here, we're going to get 80 minutes. So in this particular question, we're asked for two things, okay? One, we're given some half-life information which allows us to calculate the rate constant. This is very important because once we have that rate constant, we can use this integrated rate law to figure out concentrations at any given time, okay? This particular question asked us how much time requires to get 75% completion of this particular reaction. 75% completion means you're going to have 25% of your initial concentration remaining. So we plug those values into our concentrations, use the K from the half-life expression, and then solve for T, which in this case is going to be 80 minutes.